Welcome back. We are in another new lecture on control rectifiers. So in this lecture, we are going to cover the dual converters. The outline goes like this. First, we will introduce the converter quadrant operation. We will see the brief on dual converters. What are the operating principle of the ideal dual converter and how the practical dual converter is different from the ideal. The two important current mode, one is non-circulating and another is circulating current mode. For the dual converter, we will see what are the comparison of the different operating modes, the disadvantages, and then we will summarize our discussion. We have seen about the one quadrant converter. So what is the characteristic of one quadrant converter? The output voltage and the output current maintain the same polarity throughout the entire firing angle control range. So the voltage and the current will be having the same polarity irrespective of the firing angle. This is known as the first quadrant converter. These are generally unidirectional power flow from the AC source to the DC load. The famous example is basically the semi-converters, where both the voltage and the current at the output are positive. It operates exclusively in the rectification mode and the power flows from the AC source to the DC load. The two-quadrant converter operates either in the rectification mode or in the inversion mode. In the rectification mode, the output voltage and the current both have the same polarity. The firing angle lies between 0 to pi by 2. It operates in the first quadrant operation and the power flow is from AC to DC load. Whereas in the inversion mode, the voltage and current are having opposite polarity. Firing angle alpha lies between pi by 2 to pi. It is generally in the fourth quadrant operation where the power flow is from the DC to AC source. The key feature of the dual converters are it enables bidirectional power flow with unidirectional current. So we have seen the two quadrant converter in detail in the previous lectures. The full converter, that is the two quadrant operation, the properties are it will operate in the first quadrant as well as in the fourth quadrant. Current direction will be fixed because it is unidirectional thyristors and the voltage polarity will be reversible. So in the first quadrant, voltage and current both are positive, alpha lying between 0 to pi by 2. It is a control rectifier and power flow from AC to DC load. In the fourth quadrant, the voltage is negative but the current is positive. So alpha lies between pi by 2 to pi. So these are used for line commuted inverters and the power flows from DC to AC source. So the four quadrant operation of these output voltage and the output current for the DC motor operation are in the first quadrant, you will see then it operate as forward motoring mode. So it will operate as the rectification. In the second quadrant, it will operate as forward regeneration. So it is inversion. In the third quadrant, it will operate as reverse motoring. So again, it will have rectification. And the fourth quadrant, you will have reverse regeneration. So in the fourth quadrant, again you have inversion. So these are the four quadrant operation of the converter. The requirement for this four quadrant converter, it will need complete DC motor control. So whenever you require DC motor control, you go with the four quadrant operation of the converter. Now today's topic is the dual converters. So what are dual converters? Dual converters are basically consist of two fully controlled converters which are connected in anti-parallel, means back to back, in the configuration to the load circuit. So here we can see the circuit. So we have the first converter and there is a second converter set of thyristors. These two converters are connected anti-parallel, back to back, and that will deliver the power to the load. So the key features are it will enable the four quadrant operation and we will be getting the bidirectional voltage and current capability for the four quadrant operation, and this is essential for reversible DC motor drives. So especially for the motor drive application, the dual converters plays a very important role because for controlling the speed, we will be having the four quadrant operation. So in the four quadrant operation, the alpha value, that is the firing angle, will be different, lying between alpha greater than 90 or less than 90 for the two converters, converter 1 and converter 2. We will see the equivalent circuit. So the equivalent circuit of these two quadrant converters, where you have two idle converters 1 and 2. They are represented with two diodes D1 and D2, and they represent the unidirectional current flow. The load is typically a DC motor with the back EMF and the inductance. So if we see the equivalent circuit of ideal dual converter, here the converter will be modeled as controlled DC voltage source, and the diode in series will ensure that there is a unidirectional current capability. So there is a load, and this load is basically delivered power from two converters. So this is converter 1 and this is converter 2. So we have a DC voltage here, and the diode makes to be the power to be unidirectional. So here the two voltage, DC voltage, are connected with two diodes and through the load. So firing angle alpha 1 for converter 1 and firing angle alpha 2 for converter 2 together sum up to 180 degree for this circuit. The assumption for this analysis under the ideal condition is that the converters are fully idle and no ripples are there in the output voltage, so you get a pure DC. Negligible losses are there in the converter. Diodes D1 and D2 both allow bidirectional current flow, and the firing angle controlled by controlling the voltage VC. So these assumptions will simplify the analysis and help us to understand the fundamental operating principle of the dual converters. If we talk about the output voltage, so the voltage characteristic where the voltage in the two converters 1 and 2, where the average output voltage of the converter 1 and the converter 2, they are equal in magnitude but opposite in polarity. So they will drive the current in opposite direction through the load. So if we go by the operating principle, when one of the converter operates as a control rectifier, the other will operate as an inverter. So in the positive group converter, which will function as a rectification mode, and in the negative group converter will function as inversion mode. The mathematical relationship of the average output voltage we will have for the converter 1 and converter 2 can be written in the form V max cos of alpha 1 for converter 1 and V max cos of alpha 2 for converter 2. For a single phase full converter, this maximum value of the voltage is given by 2 root 2 V by pi. For an ideal converter, we can have the output voltage as V01, which is equal to the negative of minus of V02. So one is in rectification, other is in inversion. So if we equate V max cos alpha 1 with equal to V max cos alpha 2 with a negative, then we get cos alpha 1 is equal to minus of cos alpha 2, or otherwise we can say that alpha 2 can be represented as 180 degree minus alpha 2 to take care of this negative sign. Now from this expression we can find that alpha 1 plus alpha 2 is equal to 180 degree for the dual converter applications. So firing angle control strategy is that the firing angle will vary, maintaining that the sum of the firing angle will be equal to 180 degree. It will ensure equal magnitude but opposite polarity of the voltage. So if we go by the example, if we take the alpha 1 to be 30 degree, then alpha 2 will be 180 minus 30, which is 150 degree. So converter 1 will operate in the rectification mode and converter 2 will operate in the inversion mode. The terminal voltage variation, if we see with respect to the firing angle alpha for any ideal dual converter, so we have a rectification mode as well as the inversion mode for two firing angle alpha 1 and alpha 2 when we go from 0 to 180 degree and 180 to 0. So we have rectification as well as inversion of these voltage V01 and V02. Both are having equal magnitude but opposite in polarity. What are the issues that we face for the practical dual converters? The challenge is, although the average voltages are equal and opposite, instantaneous voltage may differ. So the consequence is that the instantaneous voltage V01 and V02 for the two converters are out of phase. So voltage difference exists between the two converters, and there is a large circulating current that can flow between the converters, and that is not through the load. So there is a solution to that, is that you insert a reactor, which is the inductor between the converters, to limit this circulating current. And provide appropriate triggering pulse to avoid the circulating current flowing in the dual converter because of the two voltages. So the operating modes of the practical dual converter can be mode 1, which is non-circulating current mode, and mode 2, which is circulating current mode. So in non-circulating current mode, one converter will be active at a time, and circulating current mode, you will have both the converters which are active simultaneously. Let us see the operating principle. So the key characteristic is that only one converter operates at any given time. Operating converter will carry the entire load current, and the active converter will receive the firing pulses from the triggering circuit. Idle converter blocked by removing the triggering pulses. So no circulating current will flow and the reactor is not required. So these are the key characteristic of the operating principle. Advantage what we get is that it will eliminate the circulating current losses and also the reactor cost involved. So if we see the circuit for the non-circulating current mode converter with a generic load. So this is the generic load where you have the converter 1 and converter 2 both connected anti-parallel with each other. Converter 1 is operating at a fire angle alpha 1 and converter 2 is operating at a fire angle alpha 2. So this load can be one of the DC motor. So here we can connect the DC motor under dual converter operation. So this will be non-circulating. Converter switching process, if we say from converter 1 to converter 2, the step 1 is remove the firing pulses to thyristors of converter 1, or you increase the firing angle alpha 1 to its maximum value. Then in step 2, the load current will decay to 0 and wait for certain delay time, maybe 10 to 20 milliseconds, and apply the triggering pulse to thyristor of converter 2. Then the converter 2 will turn on and the load current will build up in the opposite direction. So the main critical requirement is that there is a delay time which will ensure the reliable commutation of thyristors will be there. So 10 to 20 millisecond delay time has to be there for reliable commutation. What is the purpose of this delay time of 10 to 20 millisecond is that if there is a delay time between this instant when converter 1 is turning off and converter 2 is turning on, that will ensure there is a reliable commutation of all the thyristor in converter 1 group. And the consequences if there is insufficient delay is that if converter 2 is triggered before the converter 1 is completely turned off, then what will happen is that there will be a large circulating current which will be flowing between the converters. This can potentially damage the thyristors and it will cause the system instability. If you talk about the load current characteristic in the current mode, the load current may be continuous or discontinuous, which depend upon the load inductance as well as the firing angle. If we design the control circuit, it should provide satisfactory performance during both the modes, continuous load current operation and discontinuous load current operation. So proper current sensing and feedback mechanism has to be there for efficient operation. If we go by the operating principle for the circulating current mode dual converter with the help of the reactor, both the converters are operating simultaneously. So we have converter 1 and converter 2 connected anti-parallel, and there is a reactor which is connected between converter 1 and converter 2 along with the load. So both the converters are operating simultaneously, and one of the converter is operating in the controlled rectification mode, whereas other is operating in the inversion mode. And there is a reactor which is inserted between the converter 1 and converter 2. This reactor will limit the amplitude of the circulating current to certain acceptable value. So the circulating current that is may be flowing because of unreliable commutation will be controlled with the help of this reactor. So we have seen that alpha 1 plus alpha 2 has to be 180 degree, always has to be satisfied for this control law. So if alpha 1 is 45 and alpha 2 is 135, so converter 1 will be operating as control rectification because alpha 1 is less than 90 degree, and converter 2 will be operating as inversion because alpha 2 here is greater than 90 degree. So one with less than 90 will be in rectification mode, another will be in inversion mode with alpha greater than 90 degree. The voltage characteristic where the average voltage of the two converters will be equal and the instantaneous value although it may differ. So this voltage difference which cause circulating current can be essentially controlled with the help of the reactor or inductor which is connected between the two converters. So the voltage waveform of the single phase dual converter, if you see in the circulating current mode, So this is the input supply voltage that we give, which is sinusoidal in nature, and we get the output voltage V01 and V02, one in rectification mode and another is the inversion mode, depending upon the value of the alpha greater than 90 and less than 90, and these are the thyristor voltages. Load current reversal process, if we see, then the load current will reversed by interchanging the role of the two converter. It means that converter 1 switch has to be made the firing angle greater than 90 so that it operate in inversion mode. Earlier it was operating in the rectification mode. Similarly, converter 2, which was operating in the inversion mode, can be made to operate in the rectification mode if we make the alpha to be less than 90 degree. However, this alpha 1 plus alpha 2 will be always equal to 180 degree has to be satisfied. So the advantage that we will get is that there will be normal delay time 10 to 20 millisecond always will not required, and there will be instantaneous current reversible possible. So operation of this type of dual converter is very fast and it has better dynamic response. Now if we compare the non-circulating with the circulating in terms of different parameters like the converter is active or not, circulating current, whether the reactor is required, switching delay, response speed, efficiency, total harmonic distortion rating and the cost. So we can compare the two modes of operation of the current. So here in the converter, when it is active, for the non-circulating only one will be active at a time, but for circulating both are active. Circulating current will be present only in circulating mode, and the reactor requirement will be required only in the circulating mode. Switching delay has to be provided 10 to 20 millisecond in non-circulating mode, but it is negligible in circulating mode. Response speed is basically faster in circulating mode, and the efficiency is higher in non-circulating mode. When we talk about the harmonic distortion, it is higher in circulating mode and the cost is lower in case of non-circulating mode. So depending upon these parameters and our application, we can choose the non-circulating or the circulating mode of operation. What are the disadvantages that we have? The major drawback. So reactor will involve both the size and the cost. It will be limiting the circulating current, but its size and cost will be significantly high at higher power level, and it will add the weight and volume to the system. So that is a major limitation when we put a reactor. It will have low efficiency and power factor because there is a losses which will be involved during the circulating current. So it will increase the copper and the core losses in the reactor. Higher thyristor current rating will handle both the load current and circulating current, but it will increase the device cost. So complex control system is required to have precision firing angle coordination, which are the major drawback of this circulating current involving the reactor. So when to use this circulating current mode? Despite the disadvantages, circulating current mode dual converter is preferable when we have the application requirements such that the load current needs to be reversed frequently. We require fast response, 4-quadrant operation, and dynamic performance is very much critical. So there is no time delay can be tolerated during the reversible process. So some of the typical application, if we see, like reversible rolling mill drives, high performance servo system and rapid transition system. So here what is happening is that the speed changes a lot, and we need to have the current to be reversed frequently. In such case, we can prefer going with the circulating current mode. So let us revise what we have discussed. Dual converters will enable 4-quadrant operation for the DC motor drives. It basically consists of two fully controlled converter connected back to back. Fundamental relationship of any ideal dual converter is the summation of alpha 1 plus alpha 2, which is 180 degree. There are two modes of operation. One is non-circulating and another is circulating current mode. In the non-circulating, one converter is active and there is no reactor required. Circulating current mode, both the converters are active. Reactor will be required. In the non-circulating mode, although it has higher efficiency, but it will have slower response. Circulating mode will have faster response, higher losses because of reactor. So choice will need depending upon the application requirement. And it is very essential for have the reversible DC motor control application. With this lecture, we have completed the entire set of lectures in the controlled converters. Now we will go with the other topic like the choppers and the inverters. Thank you for now.